In this video, I will summarize the rules of exponents. You have seen this a little bit from the discovery activity that we did in class. This paper just kind of summarizes all the rules in one place. So before we begin, let's go over our vocabulary. Your coefficient is always the number in front. So your coefficient is the number in front of your variable. The whole thing is your power, and the variable is going to be your base. The exponent is the small number that is raised to a power. So when I use those words, you can refer to the top if you're unsure what I'm talking about. The first rule we're going to talk about is multiplying powers. So when you multiply powers, the official rule is a to the m times a to the n is a to the m plus n. Anytime you're multiplying your powers, you are adding your exponents. If there are number coefficients, you multiply them. So let's look at these two examples. X to the 8th times x to the 7th would be x to the 8 plus 7, which is x to the 15th. Anytime you're multiplying powers, you're just adding the exponents together. Now, if you look at the second example has coefficients in front. When that happens, you're going to multiply those two numbers together and then add your exponents. So 5 times -2 is -10. 3 plus 6 is 9. Again, you're multiplying the big numbers in front. You are adding the exponents. Let's look at our next rule. Our next rule is dividing powers. So dividing is the opposite of multiplying. The rule for this is the opposite of the rule for multiplying. For multiplying, we added our exponents. For dividing, a to the m over a to the n, we are going to subtract our exponents. And again, if there are number coefficients, you are going to divide those. So let's look at our two examples here. Y to the 6th divided by y to the 4th is going to be y to the 6 minus 4, which is just y squared. For my second example, I have number coefficients in front of my variable. When that happens, you are going to divide those. So you're dividing the big numbers in front, you are subtracting your exponents. -12 divided by 4 is -3. 5 minus 2 leaves me with x to the 3rd. Be careful on this. You are not subtracting 12 and 4, you are dividing 12 and 4. My next rule is when I have a power to a power. Your base is going to stay the same, and you're going to multiply your exponents together. So a to the m to the n is a to the m times n. You are multiplying those together. So let's look at our examples. Y to the 3rd squared is y to the 3 times 2, which is y to the 6th. You're multiplying your exponents together. If you have multiple bases, then each base is going to be raised to the power. So if you look at this next example, I am basically going to distribute the 3. 4 gets raised to the power of 3, x squared gets raised to the power of 3, and y to the 4th gets raised to the power of 3. You're going to look at each base separately. Well, 4 to the 3rd is 4 times 4 times 4, which is 64. Be careful here. You're not multiplying 4 times 3. You are raising 4 to the 3rd power. There is a difference. X squared to the 3rd, you're going to multiply those exponents together, leaves you with x to the 6th, and y to the 4th to the 3rd leaves you with y to the 12th. So, biggest mistake I see on this one is people just multiply 4 and 3, but remember, it is 4 to the 3rd, not 4 times 3. For this next one, I have x to the 5th over y squared, all raised to the power of 3. Each base, again, is being raised to that power of 3. So you can look at the numerator and the denominator separately. X to the 5th to the 3rd is x to the 5 times 3, which is x to the 15th. Y squared to the third becomes y to the sixth. You're just multiplying those exponents together. Our next rule deals with negative exponents. You never want to leave an answer with negative exponents. It's considered improper. So anytime you have a negative exponent, you are going to move it to make it positive. A to the negative n becomes 1 over a to the n. You move it to the denominator to make it positive. If you have a coefficient in front, like this example shows, the coefficient does not move with it. That's going to stay. So let's look at these two examples. X to the negative 8 is going to become 1 over x to the 8th to become positive. 5 over x to the negative 3 would become 5x to the third. So if your negative exponent is already in the denominator, so if it looks like this, then you're going to raise it to the numerator to make it positive. If it's already in the numerator, like this one, that's when, let's say it was 6x to the negative 4th. The 6 would stay on the top, and x to the 4th would move to the bottom. So you only move the base that had a negative exponent. Our last rule is anything to the power of 0. Anything to the power of 0 is 1. So if you look at our two examples here, 2 to the power of 0 is just 1. For the second one, negative 3x to the 0 is a little bit trickier because negative 3 is not being raised to the power of 0. Negative 3 has an imaginary exponent of 1 there. So the negative 3 is going to stay negative 3. X to the 0 becomes 1. So your final answer on this one is not 1, but negative 3. This is a summary of your laws of exponents. These are something that you should have memorized. So make sure you memorize that when you're multiplying powers, you're adding your exponents. When you're dividing powers, you're subtracting your exponents. A power to a power, you're going to multiply your exponents. Negative exponents move to the top or bottom to become positive. And anything to the power of 0 is 1.